Our next presenter is Logan Blyth, who will be presenting Automate Data Center Network Operations with Kubernetes. This is Logan's first time presenting at NANOG, and it's a pleasure to have him speaking with us today. We'd like to give Logan a warm welcome.
Hi, I'm Logan Blyth. I'm a software engineer at Hedgehog, and today I want to talk about how we use automation and what processes we go through when we are doing automation to kind of create automation, like what our thought process is when we're creating automation. And I'm going to show you what that process results in, kind of what that looks like. So I kind of tell you what we think about, and then tell you how that actually kind of like came to be for our little open source project here. And I want to start off with a question. So how do you maintain a multi-tenant CLO topology? Well, no, you don't. You don't do that by hand. You don't do that with your brain. That is a lot. Because what's the mental load of trying to create this configuration? Right? You have your six logins, you have your BGP setups, you have to do your ASNs, you have to do your route maps, your community strings, you have to make sure EVPN is working correctly. There's a lot of things that you need to keep in order, and you need to write it down because pretty soon you're going to be changing this configuration, right? You have a new switch that you're going to need on board, you have another login, you need to test your peering, you need to make sure that when you're bringing in another tenant, that your traffic isn't mixing between the two, and telemetry, and switch operating system updates, and all sorts of stuff. So it's hard. It's hard to do that. Automation can make things easier, and it's going to reduce the amount of variability that you have. And you don't always have to have an automation to create a problem or to have a problem. And sometimes we are the problem. I remember a coworker of mine forgot that he was logged into a production box and shut it down. And automation could have saved us there. But automation is code doesn't make a lot of mistakes. It will happily do repetitive things over and over again and not waste your time and not waste our time when we are trying to think of anything else other than trying to do this repetitive slew of tasks. So we will get to kind of free up our brains for thinking about other things in an automated scenario. So one benefit of automation is it's an agreement amongst your team. Right? It lets you guys make sure that you're all on the same page, and it lets you kind of write down how you do things, and it lets you reason about your network as a whole. It lets you say things like, our network allows this or does not allow that. It will forbid these things. It will help you if you're going to hand off management to the next engineer beneath you, that you kind of have your house in order. And it's kind of like a way to encode the tribal knowledge that you have inside of your group. And so how do we build it? Right? We are software developers. I'm a software developer. So I spend a lot of time building things, building automation. I know a lot of the people at this conference are network engineers, and they are people who are very familiar with operating networks. And so I want to talk about building automation as a software engineer. And the first thing that we do is we choose the right abstraction. And so an abstraction is kind of like, it's a thing that controls another thing, but you're going to be manipulating that thing. And that's like a mushy definition, and so I chose a steering wheel as an example to kind of talk about that. So a steering wheel, you move side to side, and it will send electrical signals down to your computer, and then from there your power steering gets modified, or you change the angle of your wheels or other kinds of things. And when you're building something, you want to decide on your abstraction because that's the thing that you're going to be interacting with on a day-to-day basis, but it's going to then do more complicated things kind of under the covers for you. And decide on your abstraction first and then break that into smaller pieces to then try to kind of chew through that problem. And so the other suggestion that we have is to keep your automation online. And that will, in addition to being like a backup, but it's also going to help you kind of commit to it. It'll be like a living place for it to actually kind of be there and try to kind of like be a little bit of like a public commitment, be like, hey, I want to keep this going. I want to commit to doing my job or doing this task in a better way with automation. And definitely start it on your laptop, move it to a server after you're happy. And so when we, as software developers, are also seeking to try to build something, we will not reinvent the wheel, right? So we look around, try to figure out what projects and processes are out there for us to use. There's Terraform, Ansible, SaltStack, Puppet. We talk to our friends, we look online. You guys should do the same thing when you're trying to build something, because someone might have something on their laptop that they're looking to try to share and try to kind of build, or like your teammates or someone in a similar product or project as you. And so I wanted to talk about, so I kind of told you our process of what we do. And I want to talk to you about like when we were faced with this problem of trying to manage 6 network switches inside a data center and multi-tenancy and all this other stuff. What did we do when we looked around? So we followed that advice. That was kind of our process. And so we found Kubernetes, right? We didn't have to look very hard. And that's the wheel that we decided not to reinvent. And as a software developer, that checks a lot of boxes for us, right? It's open source. It has a role-based access control. It will be a place to run our code beyond just like a Linux box. Like it gives us the ability to run containers and to run like our logging and our monitoring and alerting solutions. It can be huge, right? You can run it on 6 or 7 servers. You can run it on 1 or 2 or 1 very small server if you want to. So it kind of gives us a great place that we can put our management solution onto. And the other nice thing is it uses the knowledge of like the hyperscalers and other people like that, so we don't have to hit a lot of problems. We can just kind of borrow their code, which is freely available under open source. And it has a huge ecosystem, right? There's a ton of things that you can buy use, whatever, that you don't have to worry about like, hey, I'm gonna go talk to this guy and make sure he understands my problem before he's gonna write some code for me and fix it. Like, a lot of the stuff is already out there and you can just plug in because we're all using that like commonality of Kubernetes. So you could think about it like the narrow waist of a lot of operating systems today. And Kubernetes will manage virtual networks. So like a lot of times you can see there's CNIs and other kinds of things that will plug into Kubernetes to manage like virtual networking, but it doesn't manage physical networks. And so when we decided, we kind of like knew that going in and we decided we want to extend Kubernetes. And so we kind of made something that we're calling the Open Network Fabric, and it's running in GitHub, or it's available on GitHub. The great thing is that we are extending Kubernetes. So we're not an app running on top of it. We have used the APIs that they allow, and we've extended it to manage physical networking switches. And so that helps us a lot. And you can run and so we run an agent on our network operating system. So that's something that like Kubernetes talks to, and that agent is responsible for making the changes on the switch. We use Sonic for those. And we chose the VPC, right? So the virtual private cloud, that's our steering wheel. That's what we manipulate. We modify it. We will create, destroy, change that VPC. And the VPCs are like a virtual private cloud, something that like people are used to from Google or AWS, and you guys can like use that on your own gear now. You can use that construct or that abstraction on your own gear. And I want to show a demo of what this kind of looks like in action. So Kubernetes, and we can record it. I have it on my laptop too if you guys want to see it or I have it recorded, but we also have it on my laptop if we want to talk about it after the fact. But what we're going to see is we're going to show a demo of Terraform, which is a completely open source. It's not even made for Kubernetes, it's made for general purpose automation. So a lot of people in here are somewhat familiar with Terraform, I assume, or at least there are people in their organization that are using Terraform. And so Terraform is going to talk to Kubernetes, and then Kubernetes is going to talk to the switches. And so this is a great thing, right? Software developers love a big ecosystem because they can just kind of pick and choose and pull things from the various ecosystem bits that they need. And so I'm going to show you the creation of 2 VPCs, so 2 isolation metrics, and then we're going to test with pings that they don't talk to each other, and then we're going to peer them, so we're going to allow this communication. And then we'll see the pings flow, and after that, just a quick little trace route for it. But yeah, if you could go ahead and play the video here. So we start off with K9S, which is a huge ecosystem benefit already. So this is a text user interface that I didn't write. I don't know this person who wrote it, but they have something out there that I can just pick up and use. And so in the center, you'll see that there's there's the name column, and then there's 3 pods that we like to talk about. So there's the pod that will automatically load a network operating system onto your switch. There is the pod that runs the kind of the controller, and then there's a pod that does DHCP for things inside the fabric. And so the other nice thing is that this is a like a full interactive GUI, so I can navigate through all of my various Kubernetes all my Kubernetes processes. And so I'll show the agent. So this is the agent that's running on the various switches inside of the network. And they're basically a little process that's going to listen for commands and respond. And so they are sending heartbeats back to the controller that says like, hey, everything's good. I don't have any changes. Everything's great. Everything's great. Which is something that's very reassuring when you're trying to manage a bunch of different switches. And so here we'll show the connections. And so these are kind of we're modeling all of this in software. So you're able to think about like, oh, I have these wires, right? So this is the fabric connections go from the spine to the leafs. The unbundled connections essentially then go from the leafs to the servers. So we have this all kind of modeled in our interface so that you can add and delete these leaves after you've plugged it in, of course. You can add and delete these leaves. So on to Terraform. Terraform, like as I said before, is a general purpose automation. And so it will let you write a single file, push go, and it will do the thing that you have commanded. So it will just terraform your network or your environment, and it's an infrastructure as code project. And here I'm showing the 2 VPCs that I've defined and the connections. And so one VPC is going to have that address space, 10.0.93.10. The other one is going to have 10.0.94.10. And you can see that I've named it VPC 94 because of Nanog 94. And so Terraform gives you the ability to do like a dry run. So you're about to like make a bunch of configuration changes. You probably want to know what's going to happen before you push the button, right? And so Terraform gives you this ability to do plan. And it will run out and look at all the things that it needs to change, figure out what the change is, and then show it to you. And so you can see there's green checkbox or green plus boxes next to the lines, and all those are going to be added, right? So that's a positive change. Nothing's to be deleted. Terraform apply is what's actually going to make it happen. Happily, the people who wrote Terraform will give you a second chance to see everything and then say yes or no. So you can see at the bottom, we enter yes. We make a bunch of VPCs, and everybody is created. And so let's go back to K9S and look at the things that we've created. So if we go to the VPCs, we see 2 virtual private clouds that are available for us. We can see the IP address ranges, and then we can take a look at the connections. We know that there's no connections changing. And then we can look at the attachments, which I typo. And then we can look at the VPC attachments and see that these VPCs are using these connections, and they are this is like our isolation barrier, or isolation boundary. So server 1 is in VPC 94, so he's all by himself. This is a little script that we have to test the addition of a VLAN and kind of creating an interface. So he's going to come back up with DHCP address, and then we'll go to server 3. Oh, no, we won't. Now we'll go to server 3. And then we'll do the same thing and give him an interface, an IP address. And this is using DHCP inside of the pods that are running inside the control node. And so he gets his IP address. So then we start trying to ping back and forth between the 2 and verify that they're isolated. And so you can think about these servers as like different tenants inside of your data center. This could be like Coke and Pepsi, or Nike and Adidas. And right now you don't want them to talk. Maybe it's just Coke and Sprite. Let's say Coke and Sprite. And so right now we can see that there's no hosts, nothing's reachable, and that is kind of what we wanted, right? That's by design, that there is this isolation. So everybody's happy, nobody can talk to each other. And so you can use Terraform, or since it's a huge ecosystem, you can use the CLI. So you could manually say, like, I'm going to use this, I'm going to allow this communication. And that's a good way to kind of build up your knowledge base, right? So take your big bites, you take your bites out of your abstraction and try to like learn what you're going to be doing along the way. So that one line just saved us a ton of time, right? So those are route maps, those are advertisements, those are all sorts of things that you don't have to go through and manually manage 6 switches. You didn't have to go to different places and look at them. You didn't have to like test your traffic. You didn't have to make a mistake when you log in and get interrupted when you go to lunch. And so I kind of switched back over here to K9S. And that is the, when we run these configurations, we run them in generations. So like I have now introduced a new generation of configurations. So you can see in the center where it's 30 and 31, when that 30 becomes a 31, that means that a new configuration has been created by the controller, verified which switches it needs to actually go down to, and then it will get pushed down to those switches, right? So this is a little bit of a lag after we've done that, but that is worth it because it's saving us time and it's doing all these checks inside there to kind of maintain our consistency. And so when we switch back between our servers, we can see server 1 and server 3 are kind of both talking to each other right now. And I do a quick trace route just to kind of show that there's just a couple hops between the servers and their VPCs. So you can see that there quickly. And here again. Okay. And so I want to know if anyone, or so I guess I'm kind of open to questions now if there's a little more of a dialogue. I get the sense that there's a lot of network developers or network operators in here. So one thing that I've heard of is that a lot of people don't like the idea of automation because they don't know what's happening, right? So they're like, I'm going to use this product, and then what's going to happen? So with Hedgehog, it's an open source project. So you can go in and look at things all by yourself, or you can go in and kind of like tweak those changes yourself. But I think that's probably it for the video. And if we want to take any questions. All right. Thank you very much.